So this one is part two of finding rational zeros using a calculator when you can skip the rational zeros theorem, yeah, or not. This is actually an example where we will have this particular function that we're going to look at, this particular polynomial. So this is the graph that we get. There's no real good numbers that are coming from this over here. You know, you've got 4 crossings, right? You've got the degree 4 for this polynomial, so we're going to have 4 crossings on this one. But we only see a good one that's crossing at an integer at 2. But we do know that there's probably going to be one between 0 and 1. So the rational zeros theorem may help us out, may not, and it's going to be this little one right here in the middle between 0 and 1. If we can find that one, then that will be our second one that we need. We always need 2 when you have degree 4. We always need to find 2 from our calculator or from, you know, a shorter version of the rational zeros theorem, not the whole rational zeros theorem, where we have the list of all possible rational zeros, you know, all integers, all fractions, all of that. We just need to be able to get this little one here, the one, only the fraction between 0 and 1. And if we can get 2, then we can use synthetic division to break down the polynomial and then use the quadratic formula. Now, this applies also for when we're doing complex numbers in section 3.5 in this current book that I'm using. So hopefully that helps. But let's get started with this. Let's see how this works. I know that 2 will work, so let me go ahead and break this down. All right, so I have over here 5, negative 11, negative 13, 33, negative 6. And I know 2 will work. Drop the 5, I get 2 times 5 is 10, negative 1. 2 times negative 1 is negative 2. I get negative 15. I get 2 times negative 15 is negative 30. Add 33, and I get 3 left over. 2 times 3 is going to be 6, and that is 0. All right, it is, the remainder is 0, so that's good. That's what we want, and this is what I'm looking for my others. I now am looking at this polynomial. Now in this case, if you're good at factoring, you can actually factor this. It will work out pretty well. The only other alternative is to look at a shorter version of the rational zeros theorem. Remember, the rational zeros theorems take the multiples of this number, and that would be 1 times 5, so 1 and 5, and then the multiples of this number, which would be 1 and 3. And we take the last one here, 1 and 3, and put it, these are going to be the numerator. And these will be the denominator. So we'll have things like this. We'll have 1 over 1, 1 over 5, 3 over 1, 3 over 5. And this is a smaller version because of using the smaller polynomial instead of the original one. But remember, for these, we end up getting plus or minus 1, plus or minus 1/5, plus or minus 3, plus or minus 3/2, or excuse me, 3/5. I don't know where that 3/2 came from. So, but if I go back to my picture, I know when I'm looking at this, I'm only going to be taking the positive version. So, and this value here is not going to be 1 or 3. So I know that 1 and 3 is not going to count here because of the way that the table looks. You see where the table, those aren't there. And I know that the negatives aren't going to work either. It's going to be something positive. So I know that 1/5 and 3/5 are my choices. Now you can use that technique on your calculator when you are looking for the intermediate value theorem. You can use that using the calculate button and then 0, picking that, and you can go through the steps, do left bound, right bound, guess, that type of thing. Or you could just try these on in synthetic division as well. So I'll tell you what, let me try the 1/5 and see if that works. Sometimes students will shy away from using fractions here, but you have your calculator, so it shouldn't be too bad to do a fraction. I drop the 5 and I get 1/5 times 5. Okay, so on my calculator, type in 1/5 times 5, and what I'll get is 1. Add that to -1, I get 0. 1/5 times 0 is 0. I add that and I get -15. 1/5 times -15. Again, if you're not good at fractions, it's okay. Just type it in your calculator, and that is -3. So now what I have is 5x squared minus 15. And when I set that equal to 0, this is pretty easy to solve. You can also factor it, just where you are just looking at this. I divide both sides by 5, and I'm really just looking at this right here. But I still have to solve for it. So x squared is equal to 3. X is positive or negative the square root of 3. And these two actually do count. The positive and negative square root of 3 counts, and that's what you would type in as your answer, along with 2 and 1/5. So the way I would do it, I would just go 2, comma 1/5, comma square root of 3, comma negative square root of 3. That's what you want to put in. Those 4 is what you'll put in for your answer. So this is just one way of doing it. There's always multiple ways. I just wanted to show you how to use the rational zeros theorem, not in its big state, but in a smaller state, how you can keep it a little more simple, so because it's a bit overwhelming seeing that long list of possibilities. But again, it's just a list of possibilities. It was created and developed before calculators were in use. And so hopefully these pictures can help you see what I'm hoping that you'll use your calculator for to help speed things along so it's not so daunting. I hope that helps. Thanks.